Hello, welcome to part 3 of managing series of tasks. So in part 2, I introduced the task async stream of RT3. So this async stream, we saw how it's much preferable to use when managing a series of tasks compared to the combination of the inner map and the task async function. So here in part 3, I want us to explore more on how the task async stream works. And I had already told you that it takes in an enumerable and returns for you a stream function, which has an intent on the task to be performed. Stream function are a lazy enumerable, and they usually don't apply transformation to the enumerable given immediately, but only when explicitly told to. So for example, let's look at how the async stream. So I'll demonstrate again how the async stream works. So let's define the task async stream. So I'll give it a range of numbers, which is an enumerable in this case. Pass to it an anonymous function, which iterates through the given numbers and perform the task given and perform the task subjected to concurrently. So I will make this anonymous function increase the numbers by 1. So if I press enter, you'll see that the final output is a stream function. So if we don't want the stream function as the final output, you can apply this transformation by calling the enum function. So for example, you can use the enum to list function. It depends with the use case how you want the final output to be. So here I've used the enum to list, and it returns for me a tuple of a list of the tuple atom okay, and each number increased by 1. So another thing is that the async stream takes in options. So these options are given in a keyword. So the options are used to control the level of concurrency. It can be used to control the time tasks are allowed to run, also the ordering of the results and the action to take when the task times out. So let's see the available option for the async stream. So the first option we are going to look at is the max concurrency. So remember earlier I told you that the difference between the async stream and the combination of inner map and the task async is that with the async stream, we can set the number of processes running at the same time. So this option is possible with the max concurrency option. So by default, the max concurrency is set to the number of logical cores available in the system. So for you to know the default number of logical cores, you can use the system schedulers online function. So if we do the system.scheduler online function, you can see that the number of my logical cores are 10. You can also use the system scheduler. It returns the same number of logical cores. So this the default limit set can affect the time it takes for the task to complete. So that means if my machine takes 10 logical cores and another machine B takes 20, it means that machine B will take longer. I will take less time to complete the task given compared to my machine. So to bypass this, you can increase your maximum concurrency option. So I'm going to use an example here that I defined in the send message application. So in here, I defined a function called notify all asynchronously with async stream, takes in a list of numbers. So the async stream will iterate through this list of numbers and start a process for each number, which will be responsible for sending messages to the given numbers. So the first thing I want us to do is to import our send message. So let me comment this out. It will be used later to demonstrate something else. And I want to delay the processing of sending message to 3 seconds so that we can be able to demonstrate the max concurrency option. So the first thing I want to do is to import this. So let's import the module name. So after importing the module name, I'm going to call the notify all asynchronously with the async stream. So before I call that, let's change this. So this was what I was using before to test. So I want the async stream to use the default concurrency limit, so which is 10. So I'll go ahead and compile, then call our function and give it a list of numbers. So I'll give it a number 1 to 10. So for us to see the final output, remember we have to call an enum function. Okay, so this has been much faster and hard to see. So let's increase the numbers instead of 1 to 10 because my logical cores are 10. Let's increase to at least 100. So you can see that 10 processes are running, another 10, another 10, another 10. So this will go on until 100 messages have been sent out and we get the result back. So the result we're expecting is the result that the send message returns. So the send message returns an output as a tuple of an atom K, received status, the created at, and the given number. So here we have the list of the send message output for each given number. Okay, so this is using the default. So let's decide and increase this number to 20. So the max will not use the default value, but set the max concurrency. Let's set the max concurrency to 20. So we have to recompile so that the changes can be detected. Then run this again. So I'm expecting 20 processes to be started, then another 20, and so on until 100 messages have been sent out and we get the result back. So you can notice that this has been faster compared to me using the default max concurrency. So in order to bypass your default, you can increase it, or even if you want to make it slower, you can as well decrease it. So it depends with the use case and how you want to use the max concurrency option. So let's look at another option available. So the next one is the ordered option. So this returns the result in the same order given. So that means it defaults to true. So when you, let's come back here. Let's look at, let's use a smaller range of numbers, 1 to 5. So remember the ordered option by default is true. So the result will be returned in order that it was given. But there is a limitation for this. So let's say that there's a task within the range one to there's a task that takes longer to be processed. So if we set the ordered as true, it will mean that a sync stream it will mean that a sync stream will have to wait for this task that is taking longer to be processed to complete, so as to move to the next option or the next task to be performed. So in order to bypass this option and to prevent the sync stream to be idle waiting for a slower text to complete, we can pass the value as false instead of using the default value true. So when we go to our async string function, we can add the ordered option and set it to false. So this way, the async stream will not have to be subjected to wait for a slower process to complete in order to process the next items in the line. So first, let's so this has been ordered to false. Let's introduce a slower process. So I want that whenever we are sending a message to a number 3, we assume that that task is taking longer to be processed. So I can reduce this to 4. Let's assume that this task takes longer to be processed compared to the rest of the tasks. So I can comment this out. And we set our ordered to, so here we have set it to false. Let's discard this, and we use the default one to demonstrate how it happens. We can recompile. Let's run again. So we are using the so we want the result to be returned the given order. Yes, so the results have been returned in the given order, but you can see that it took time. Let's run this again. You can see the message was sent to 1, 2, 4, 5. 3 is taking longer to be processed, but for us to receive the result in the order given, we have to wait for the task of the number 3 to be completed in order for us to get that result back. I can run this again. Okay, so now let's bypass that option by passing it to bypass the default. So ordered by default is false. We have to compile to detect the changes, then run that. So we don't have to wait for this to be, so our sync stream don't have to stay idle waiting for this task to be completed in order to move to the next. So it will just proceed with the next item while this is processing. And once it completes, the result has been returned back, and you can see that the order is not as given as the input given. Okay, now let's move to the next option. So the next one is the timeout. So this one is just to determine the maximum amount of time each task run. So the default is 5,000 millisecond, and it can be passed as a millisecond or as infinity. So back to our send a message application. So if I don't pass the timeout option here, it assumes that the default, which is 5,000 millisecond. So let's say the task for number 3 takes longer than 5,000. So I can put it here 7,000 millisecond. So this determines the timeout of a given task. So I'll recompile this. So if we try to notify all or send message to all the given numbers and the number 3 is taking longer to process, let's see what will be expected. So it's trying to send a message for all the numbers except 3. So for the number 3, we can see that it's the timeout is exceeding the limit and our stream has been stopped and the process is also crashing. So we haven't yet received the final result, which is the list of the tuple of an atom. Okay, the status received and the created at time. So that being the default, it means that we can either increase this time or also pass it as an infinity. So let's try and increase the timeout so that we can give the task for number 3 time to be processed. So let's increase this timeout. I can increase it by maybe using, let's use infinity so that it does not time out at all. We expect all messages to be sent out. Yeah, so as expected. So the same thing will happen if we increase the timeout to maybe 6,000 milliseconds. No, 6,000 is less than 7, so let's increase it to either 9. So with that, we expect all the messages to be sent as well. Yeah, so it has worked out as expected. Now let's look at the final option that we have. So we have the on timeout, which determines the action to take when task timeouts. So what does this mean? So in the first example, while so I can't see it, but let me demonstrate again. So if I remove the timeout option here, it will default to 5,000 milliseconds. Remember the message being sent to number 3. It's taking that task is taking longer to be processed, and it delays with 7,000 milliseconds, which is more than the 5,000 milliseconds. So which is the default of the async stream timeout. So in that case, it will mean that if we try to send these messages out, it will not be successful. Let me try to recompile this first. It will not be successful because the 7,000 is beyond the default timeout, and the stream will be stopped and our process crash. So the default of on timeout is exit, and just as you have seen, using this default value of the atom exit, result to the task exiting the timeout to stop the stream and also crashing the current process. So for us to prevent this process from exiting when the task has reached the timeout, we can set the value to kill task. And this will mean that the async stream will be able to ignore the task that is taking longer to be completed and carry on as normal. So instead of async stream crashing at this point, we can decide to use the kill task for the on time option. So let's use the on timeout, sorry. So let's use the on timeout option and set it to kill task. So when you set it this way, that means our stream will not be stopped, neither will the process crash. So still the task in number 3 will take 7,000 milliseconds, which is more than the 5,000. Remember that the timeout is not increased, so it's using the default. So we are expecting the result back as usual, but the message not to be sent to the number 3, and also don't expect the result for the output of the message. We don't expect the output from the number 3. So as you can see, the message has been sent to the number 1 to 10 except 3. So the number 3, which was taking longer, we can see that it exited with the reason timeout. So these options, for you to use this option depends on the use case. You can decide to let it crash when the timeout has been exited. That's it. Also, you can decide that you want the result in order or not. So that depends on the use case. You can also decide to increase the level of concurrency or decrease it. So all this depends on the use case and how you want your final result to be.